everyone, and thank you for joining us. Our project, Geometry of Space, Promoting Spatial Reasoning with Augmented Reality, is all about using AR to engage Year 2 students in learning geometry. The goal is to help them creatively solve space-related problems that they might encounter in everyday lives, using an interactive digital environment. With AR, we're not just teaching geometry, we're bringing it into life in a way that traditional textbooks and static images cannot. This approach allows students to visualize and manipulate shapes, making learning both engaging and practical. The main learning objective is to have students to evaluate different spatial arrangements of geometric objects in AR environments. They will practice spatial reasoning by selecting and justifying the most effective layouts based on 3 criteria. First, space efficiency. Students will need to decide which arrangement makes the best use of available space. Second, functionality. They'll evaluate if the layout is practical for everyday use, thinking critically about the needs of the space. And lastly, safety. They will learn to identify potential hazards in an environment and adjust the layout to enhance safety. These skills aren't just for geometry lessons, they are essential for making well-informed and practical decisions in a real-world context. Why use AR to promote spatial reasoning? Augmented reality has unique benefits that make it an ideal tool for teaching spatial reasoning. Firstly, it promotes interactive learning. AR allows students to manipulate objects in 3D space, helping them better visualize complex geometric relationships. This hands-on experience is far more engaging than the traditional 2D diagrams or static 3D models, as it turns abstract concepts into tangible ones. For example, students can rotate objects, examining them from different angles, and make changes in real time. Next, it applies real-world context. Using AR, students aren't just looking at geometric concepts in isolation, they are applying them into a real-world scenario. They might arrange furniture in a virtual bedroom or design playground layouts using spatial reasoning to tackle everyday challenges. This contextual learning bridges the gap between abstract geometric lessons and practical applications, making the subject relevant to their daily experiences. Next, enhanced engagement. AR is inherently engaging because of its immersive, virtually stimulating nature. It makes learning dynamic and interactive, encouraging students to wonder, experiment, and explore. This fosters creativity and problem-solving skills, keeping them invested in the learning process. With AR, geometry isn't just a subject to learn, it's an experience to interact with.
Closer look at the AR environments we've developed. These are videos of a scenario with 2 virtual bedrooms. Students are tasked with evaluating the space, considering efficiency, functionality, and safety. Using it in these environments, they can move around the room to see how different layouts impact space usage, whether objects are life-size, test various furniture arrangements to determine the most practical setup, and to adjust the position of objects to ensure the space is safe for people to navigate. This experience allows them to actively engage with geometric concepts, experimenting with different configurations until they find the most viable solutions. It's about making mistakes, trying again, and learning through doing, a key component in developing strong spatial reasoning. To gauge how well students grasp the concepts, we've designed assessment tasks that are both practical and reflective. Here's what we'll be asking them to do. Firstly, assessing efficiency. Students will compare 2 different layouts and choose the one they believe makes the best use of space. They'll need to explain why they chose one layout over the other, emphasizing the importance of clear reasoning. Next, functionality. They'll assess the usability of their chosen layout for daily activities. If a setup isn't practical, they'll be asked to propose changes and justify why those adjustments improve functionality. Lastly, safety. Students will rearrange objects to make the space safer, considering factors like pathways, accessibility, and potential hazards. They will explain their thought process, reinforcing their ability to critically assess an environment.
In summary, this project is about developing mathematical thinking and skills through AR, where students can firstly enhance problem-solving skills by evaluating different scenarios and making decisions based on criteria. Second, boost creativity as they explore multiple ways to organize a space, encouraging them to think outside the box. Lastly, develop confidence in their decision-making abilities, a critical part of mathematical thinking. But the impact goes beyond geometry. AR has the potential to revolutionize learning in other subjects too. Imagine virtual science experiments where students manipulate chemical compounds, historical reenactments that brings the past to life, or interactive language lessons that makes vocabulary tangible. Its immersed nature supports different learning styles, catering to visual, auditory, and kinesthetic learners alike, making it a versatile tool that can transform education. Thank you for your attention. We're excited to showcase how AR can be a game changer in education. It's not just about teaching students to memorize facts, but about giving them the tools to interact, explore, and experience knowledge in ways that inspire curiosity. We can't wait to see how AR will continue to evolve and transform classrooms, making learning not just informative but truly engaging. Thank you.